There are two types of ice that you find in the solar system. There's the crystalline ice that you will find in your freezer, but there's also a type of ice called amorphous, which lacks a regular geometrical pattern for its molecules.
Amorphous ice is not something you naturally find on Earth because the temperatures and pressures are much higher on Earth.
The way that we make our ice is we use a small evacuated chamber. We pump all the air out. We have a small metal disc about the size of a quarter that we cool down to just a few degrees above absolute zero. We flow a gas on top of it, the gas freezes on the metal, and we can study the way that light reflects off that metal to tell us what the ice is like.
So one of the things that makes our lab unique is that we can study cosmic ices when they're exposed to high-energy protons from a Van de Graaff accelerator. So we can bombard our ices with protons that have 1,000,000 volts of energy. The data that we measure can be used in order to interpret observations that astronomers make of cosmic ices in space. Most people would put compounds in liquid water at room temperature and study the chemistry like that, but we're studying the chemistry in ice at extremely low temperatures. Historically, people may not have thought that there could be any chemistry at those temperatures.
We're able to study things in space without leaving a laboratory. At NASA, we have people who build spacecraft and fly distant places in the solar system. We collaborate with them, and by combining the laboratory work we do with the spacecraft work that NASA does so well, we're able to actually study the chemical composition of things throughout the solar system and in some cases throughout the galaxy.